All right. We are in section 6.3, where we're going to use similar polygons. Similar polygons are two polygons where corresponding angles are congruent and corresponding sides are proportional. So we talked about congruent figures earlier in this course, and the definitions were very similar, except for with congruent figures, the corresponding sides had to be congruent, but in this case, we're asking that the corresponding sides are proportional. So, same rules apply. When you look at the statement that they give us, we have to make sure that the order of the angles meets with the order and how it's placed with the similarity statement. So first off, I have corresponding angles. So like the first letter is A, so that means that angle A is going to be congruent to the first letter in the second polygon, which is angle E. And keep on going, angle B is going to be congruent to angle F, and then angle C is going to be congruent to angle G, and then finally angle D is going to be congruent to angle H. All right, same thing with the corresponding sides, except they won't be congruent. We're just going to say that if you look here, the first one is AB, first and second, EF. So AB and EF are corresponding sides. They're not congruent, they're just corresponding. And then the next one, we're going to say BC and FG. So BC and FG, comma. Next, we're going to go CD and GH. So CD and GH. And then finally, we got AD and EH. Okay. And then the final thing, this is what we can write something with that's an equal sign. It says the ratio of the corresponding sides. So what you get to do is you have to pick which one you're going to denote as the denominator and numerator for that particular polygon. All right, I am going to use the first polygon as my numerator, and then the second polygon as my denominator. And you have to be consistent throughout the entire process for it to be true. So everything that's going to be on top are sides from the first polygon. So I can say that AB, the ratio of AB to EF is going to be equal to the proportion of BC to FG, which is going to be equal to the proportion of CD to GH, and then finally it's going to be equal to the proportion of AD over EH. Now, if you wanted to put the other polygon in the numerator, that's fine. You just have to be consistent throughout the whole process. Okay. Let's take a look. So here in this example, it says in the diagram, A, B, C, D, E is similar to F, G, H, J, K. All right. The first thing they're asking us is they want us to find the scale factor of F, G, H, J, K to A, B, C, D, E. Okay. This is where you have to keep in mind and be very, very careful where you put the values in your proportion or in your ratio, because there is a right and a wrong way to do it. So if you look at the wording of the first problem, it says it wants to find the scale factor of FGHGK to ABCDE. So the first one here is this polygon. So that means they're already telling us that they want that polygon to be denoted on top. Okay, because if you recall, there are the different ways that we can write a proportion: A over B, A to B, and A to B. So they use essentially this model here, and that allows us to format it in the other two ways, if that makes sense. So we look at it, find the scale factor. All you got to do is look at just one corresponding side. So I can just take a look and say like, oh, FG is 15, and the corresponding side is AB, and that's 10. Well, I can reduce that 15 over 10. I can reduce that to 3 over 2. So the scale factor of FGHJK to ABCD is 3 over 2. Okay. The second thing they want us to do is they want us to find the value for x. The value for x comes from the side AE. All right, so you could write a proportion and say that, okay, since I know that 15 over 10 is going to be equal to, and looks like it's going to be FK and AE, so 18 over x, you could write that proportion, do the cross products, and you would get 12. Or you could also take 3 halves, which is 1.5, and we could do what? Divide it by, divide it by 3 halves? So it would be 18 divided by 3 halves, which you'd also get 12. But I would suggest this route more often than none. So if you were to take 15x, set it equal to 180, and divide both sides by 15, x would be 12. Okay, so I'm just going to put 12 right here. And then the last thing is they want us to find the perimeter of ABCDE. So you know that this is 12, and I also know that ED is 10, because if you look here, I got 15 and 15, and since they're proportional, you know, I can write that in there. The next thing I can do is I need to find CD and BC. You can use the proportion values and say that, okay, so since 15 over 10, it's going to equal 12 over some value, I'll just call it y. So you got the cross products of 10 times 12, which is 120, divide that by 15, and you get a value of 8 over here. And then you can do the same thing and say 15 over 10 is going to be equal to 9 over, we'll just call it z. I don't have a variable for it, so then this can be 90 over 15, which this gives me 6 for BC. And then you just add them up. So 10 plus 6 plus 8 plus 10 plus 12 gives you a value of 46. Okay. Looking here, in this example, it says 2 similar posters have a scale factor of 3 to 2. The smaller poster's perimeter is 108 inches. They want us to find the larger poster's perimeter. Okay, so posters are usually as a rectangle, so I just kind of look at it like this. And the perimeter of this one is 108, and they're telling you that the scale factor is 3 to 2. So essentially, what you can do is you can take this 3 to 2 and you can multiply it by the perimeter of the smaller poster. So if I were to take 3 over 2, which would be like 1.5, and multiply it by 108, I would get a perimeter of a larger poster of 162 inches. And that would be it, because it didn't ask us for anything else. And that is being able to use similar polygons. Hope this helps. Until next time.